Hello everyone, welcome to my YouTube channel. And the question for today is Pacific Atlantic water flow. Alright, so what we have over here is the question where in which given a matrix m cross n of non-negative integers representing the height of the each unit in the continent, like Pacific Ocean, what touches the left and the top edges, that is the left, and the top edges is the Pacific, and the Atlantic Ocean touches the right and the bottom edges. So here we have Atlantic and here we have Pacific. All right, and in between the cells that are given as a heights. All right, so water can flow in 4 directions. And so water, the main reason for the heights given is that the water can flow from one height to another only if it's equal or lower. All right, yeah, so only if it's equal or lower, that is a very important condition over here. So let us look at this. Like, this is Pacific and this is Atlantic Ocean, and these are the heights that are given to us in a form of an 2D matrix. And water can only flow from a height that is that is bigger to lower, because water can flow from only high to low, right, not low to high. Right, so that's the same thing that is given in the question as well. So water can flow from a height that is bigger than to smaller one, and yeah, so and it can flow in only 4 directions, not diagonally. It can flow only in up, down, left or right direction. All right, so we find the list of the coordinates where water can flow to both Pacific and Atlantic Ocean. So we have to find the coordinate from, if we place some water drop or something like that over there, the water will flow to both the oceans. All right, the Pacific as well as the Atlantic Ocean. We have to given the coordinates. All right, we are not given their heights, but we have to return the coordinates. All right, so coordinates, because coordinates are unique, height can be repetitive, so our answer would be wrong in the case that's why the question is designed like we have to return the coordinates. All right, so one note given over here is that the order of return coordinate does not matter. So basically it doesn't matter. It's not like we have to return the lexicographically smaller one or like that. So we have just to return the coordinates, and both m and n are less than 150, so the maximum size could be 150. All right, so yeah, that's the question over here. And let's see the example over here that's given to us. And in this example, what it's given to us, that these coordinates. So what is 0 4? 0 4 is 0 1 2 3 4 and 0. So this coordinate. All right, if we place water at this point, definitely if it's at higher end, it will flow to this and it will flow to this, so it can flow to both oceans. All right, and yeah, and the other coordinate that is given to us is 1 3. So it is 1 3. Okay, 0 1 3, that is 7. Alright, so water can flow to this side and this side, and it can flow to both the oceans. Like this, it touches this and it touches this. Alright, so that's the main thing over here. And okay, and also because they have encircled the points. So for this point, why is this point is included? Because the water can flow from here to this ocean and from here to this ocean. All right, so up, down, left, right. All right, and only the heights which are lower than that. All right, not the higher heights. All right, so yeah, so why this point is not in our answer, guys? Because the height is 3 and all the adjacent heights are like, say it can flow this side, but it can't flow this side because all the heights are greater than that. It's 5 4 4, so it cannot flow from 3 to 5 or 3 to 4. All right, so that's why it's not included in an answer. It's not like we have to give a path from that particular point. We have to give a points from where, if we throw some water, it will meet both the oceans. So that's why 3 is not included in our answer over here, and it's not marked like this. So yeah, I hope this example is clear to everyone, and there are no constraints given. So we will assume that these are general constraints, because they have written some constraint in these only, that the numbers are non-negative, that is they are positive, and the size are less than 150, and the order, it doesn't matter. So it can be 0 as well, because it's not mentioned in the constraint. We will cover this test case as well. If mentioned in the constraint that the minimum range from the m or n would be from 1 to 150, then we can skip the part of having a null matrix, but it's not specified over here, so we will assume that we can get a null matrix. All right, so yeah, that's the question. I hope it's clear to everyone. And a basic hint for this question would be a graph approach. All right, because a matrix is a kind of a graph only. And yeah, so and we have to find, these are like connected in a way, so it would be a graph question only. And let's see how we are going to solve it. All right, so let's see the approach for this question. And yeah, this is the question, and we will see the approach with the help of an example first, and it would be much more clearer how we are going to solve it. All right, so this is an example over here. So what we do is simply the way we have to locate the points from which we start and we reach the both the oceans. And yeah, and we can only move from and we have to give the point from which we start. All right, not the path from the points. That's a very basic thing that should be cleared while we write the code for this question. So the idea here would be not to start from the points, but to start from the ocean. All right, and as I discussed earlier, it's similar, it's a graph like question. So it's a graph like question, so basic graph traversals algorithm can be used over here. All right, so that shouldn't be any concern. So what to use? So we can use both BFS and DFS. I'll implement BFS because it's much of a iterative solution than a recursive one, and very easy to understand. Sometimes people have difficulty in DFS because it's a recursive solution, but that doesn't concern us. The main concern is the approach that we will be using to solve this question. All right, so as I said earlier, we will not start from the points, but we will start from the ocean. What I mean by that is that given a matrix like this, we have over here is, I think, a Pacific is there and Atlantic is here. All right, so what we do is that, because these points can directly be covered with the ocean, because these points can cover the Atlantic, and these points these points can cover Pacific, and these points can cover Atlantic. Now we have to find the common points. All right, so the approach that was given to us in the question, that we have to go from higher high tile to lower tile. All right, as we are using the backward approach or the opposite approach, so what we will be doing is we will be going from lower height to higher height. All right, to find out the points. And what we are going to do is we are taking these 2 points from the inner queue, and we're gonna apply BFS at them, and we are gonna find the points. Similarly, we are going to do the same thing, keeping in mind the points will only be added to the queue or at the list where we are storing them, only be then be visited only and only then when they move to a point which is higher than them, not lower than them. All right, so because this condition was when we move from point to ocean. All right, point to ocean. Now we are moving from ocean to the point. We are using this approach, ocean to point. All right, so this thing we would be keeping in our mind. All right, after, suppose we have got some values, then we will select for the common one. All right, now let's try to solve this question and let's see what we can get. All right, so yeah, I have marked over here with this blue are the Pacific Ocean point, because here is the Pacific Ocean, and we can move from, suppose, 3 point to this point and this point, because it's of equal or higher length. Alright, similarly we can move from this point, this point, this point, and this point. We cannot move from this point to this point because it is of low length, not this point can be covered from here. So yeah, these are all the points that are covered from the Pacific. Similarly, I have done here for Atlantic, because these are the points that touches the ocean, so this can be covered directly. From now we will apply our algorithm, because it's at higher height we can cover it, it's at lower we cannot cover it. All right, now we have the, now what we have to do, we have to find the only the common points. All right, had it our algorithm be opposite, that we check from every point, it would have taken a lot of time. This algorithm now saves the time and cuts our complexity even to, you can say, half from the algorithm where we traverse every point. All right, now after that we can have the common point. So here I have marked the common points with yellow. So these are the common points, and at the end what we have to do, we have to just return the coordinates. All right, so I hope this approach is very much clear. It's a very easy approach. What we are using here, we are just doing the opposite. We are going from ocean to the points, and we calculate both the points from Atlantic as well as Pacific, and at the end we return the common points, because only the common points can let us to both the oceans if we start from them. All right, and if we start from any other point, we cannot get to the ocean. We either get to Pacific one or Atlantic one, we cannot get to both of them, so only the common points will get. All right, so yeah, this is the approach we are going to use for every, every traversal. Like for Pacific and for Atlantic, we will be maintaining two queues for visited like that, because we don't want to go in a infinite loop if we don't know what points we have visited and what points we are about to visit. All right, so we are going to maintain a queue for both of them separately, and I hope this approach is clear to everyone, and it would be much more clearer if you have still have some doubts. It would be much more clearer when we see the code for this question. All right, so now let's see the code for this question. Yeah, so these are the points, because we can move in specific coordinates. So I have taken these points in as my directions, and this is a general principle. If we solve any problem for traversal as well, we keep the points where we can move in an array initially, and we apply our algorithm. All right, so this is general. So number of rows, number of columns, these are nothing. This is our main function, which have the coordinates. All right, and we have to return a doubly array list. All right, integer value. All right, so we have put a check for 0, because if it's an empty array or it's 0, then we simply return empty as the answer, because we have to return an array list. So that's why we have returned an empty array list. We haven't returned values like null or 0, because the return type is that. All right, now we have taken the number of rows and number of columns as like that. Now here we have maintained two queues, one for Pacific and one for Atlantic, because we are applying BFS approach over here. So we are using queues. Had it been DFS approach, we have been using stack. All right, so yeah, BFS approach, and now we are adding every point that covers the Pacific Ocean and the Atlantic Ocean. All right, how we are adding them, because these are the points that will cover the Pacific, and these are the points that will cover the Atlantic. So we have applied a loop like that, because at all these points we will begin our BFS approach. All right, because these points will be initially set to the queue and a BFS would be applied. So how many nodes are how many values are visited, we don't care. We just care for the common ones that are visited by both. All right, so what we do is we initially offer these points for Pacific and these points for the Atlantic. That is done over here, and now we have deployed our BFS code, which is written over here. That's basic simple logic BFS code, and after that, when the result will be covered in both, where basically are the coordinates that are true, because I have taken a boolean that will return true it's visited and false if not visited, and and at the end we'll compare the common ones. So I have traversed whole of the array. If both of them are true, that means they are visited in both the loops. that is they are visited by Pacific and that as well as Atlantic. So yeah, I will pick that point and add it to my final answer, and at the end I will return that value. Alright, now let's see the code for the BFS approach. Alright, so here is the code that I have used for the BFS approach. Alright, so it's a simple code. I've taken a matrix for determining whether it's visited or not, and it's for the same number of rows and columns that is of initial matrix. And yeah, this is a simple BFS code. While the queue is not empty, we will simply pop the element, and yeah, we will mark it true, and we will go in the directions, and we will check that if the point doesn't exceeds the matrix. If it doesn't exceed the matrix, then we continue, and if it hadn't been visited, then also we continue. And yeah, now we only add those points that we move from lower to higher, because we are moving from ocean to the points. We are checking for lower height to higher height. Had it been the opposite, had it been we have been checking from the points to the ocean, then we have just simply reverse this check. All right, and at the end, if all these conditions are satisfied, if because we are covered over here, then what we do is we add it into our final queue, and at the end we return our reachable, because when the queue will be empty, and that means we have traversed every point. And yeah, and the visited array, the boolean reachable array, or the visited array, reachable in this case, would be set, initially values will be set to true or else. All right, I hope this driver function or the BFS code is also clear to everyone. Let's try to submit this code. As you can see, it's accepted. So if you have any doubt regarding this question, or you have any doubt, you can ask me in the comment section. And if you like this video, please like it and subscribe to my YouTube channel for more such videos. Thank you for watching. Bye bye.